Benzoin condensation. Aromatic aldehydes like benzaldehyde, furfural, when treated with ethanolic potassium cyanide and reflex, it undergo dimerization to form keto alcohol. This reaction is known as benzoin condensation because when we use benzaldehyde, C6H5 CHO, we will get, that is in presence of KCN, we'll get the product which is known as benzoin, C6H5 C double bond O COH C6H5. This product is known as benzoin. Okay, and this is a keto alcohol, so it's a ketone and alcoholic group, both are present, so that is why this reaction is known as benzoin. Now let us, before going to the mechanism, we can find that a few examples of benzoin type condensation can also occur in aliphatic compounds, but usually it follow the aldol condensation mechanism. And nitro and hydroxybenzaldehydes as well as cinnamaldehyde, they do not undergo benzoin condensation, whereas some of the halo and para-dimethylamine benzaldehydes give a very poor yield of benzoins. Okay, so let us see the mechanism of this reaction. The first step is the addition of cyanide ion to the aldehyde followed by the proton transfer to form a cyanohydrin. So the first step is the formation of cyanohydrin. So we can write it as C6H5 CH double bond O. So this is our benzaldehyde, right? So on to this the addition of cyanide ion is taking place. So cyanide ion is having the negative charge and we have the electrophilic carbon here in the carbonyl group, and here the pi electrons will shift to oxygen, so that we'll get C6H5 CCN H and O minus. Okay, and a proton abstraction will take place here. So water is there. So what happens? So here water is having two lone pairs, right? So here what happens? Here it will, this anion will abstract a proton from water and OH minus will be eliminated. So here OH minus will be there, right? And what you will get? You will get C6H5 CnHOH. This is nothing other than cyanohydrin. This compound is known as cyanohydrin. So next is the formation of cyanohydrin of benzoin. The formation of cyanohydrin of benzoin. So how it is formed, cyanohydrin of benzoin? So this cyanohydrin contains one alpha hydrogen. So we know that this is alpha hydrogen. So if you see the cyanide group, this is the alpha carbon to the cyanide group and this is the alpha hydrogen. So alpha hydrogen attached to a cyanide group is acidic in character, right? So this can undergo a base catalyst addition to the carbonyl group. So first is the deprotonation of the cyanide, alpha hydrogen of the cyanide group. Because of this acidic nature, it will move as H plus. So in presence of a base, so let us consider the base OH minus. So what will happen in presence of a base? This base will take up the H plus and here the carbon will gain a negative charge. So it is, so carbanion is formed. One carbanion is formed. We can say that in intermediate carbanion. So this is the intermediate carbanion that is formed. So we can write it as C6H5 CnOH and the carbon is having the negative charge. And this intermediate carbanion, so we have a carbanion and this intermediate carbanion will attack another aldehyde, that is a second aldehyde. So we have the aldehyde here, so C double bond O, which is our aldehyde, benzaldehyde, and hydrogen. So here base catalyst addition is going to take place. Here the carbon, it will attack the carbon, then the pi electrons will shift to oxygen, so that we will get the addition product as, so what will be the addition product? Let us see, it is C6H5 CCNOH. This part I have written, and here I am writing this carbon, so onto which the addition has taken place. So carbon is there, carbon is having one hydrogen. What is remaining? O minus. So O is having the negative charge now because the pi electrons are shifted to oxygen, and remaining is C6H5. Right? Now again what will happen? Here O minus is there, so the protonation of oxygen will take place. So how the protonation will take place? When the protonation takes place, here it will be OH minus, right? So let us consider water is here, right? So what will happen? This will abstract one proton, so that minus OH minus. So this will result in the compound C6H5 CCNOHC. Here now it is protonated, so it is OH H and C6H5. So this is the cyanohydrin of benzoin. So we got cyanohydrin of benzoin. Okay, cyanohydrin of benzoin we got. Now the third step is the formation of benzoin from cyanohydrin of benzoin. So how it is formed? Again, in presence of the base, a deprotonation will take place at this hydroxyl group. So what will happen? Here we have a bond, right? So this OH minus will abstract this H plus, and the oxygen will have the negative charge. So it is C6H5 CO minus CN COH H C6H5. Now this electrons will shift. So this is the final step in which a Cn minus is removed, or by the elimination of Cn minus will ultimately it will form HCN. Okay, so here the Cn minus will be removed, so that it forms, so here it is minus Cn minus C6H5 C double bond O C OH H C6H5. So what is this? This is benzoin. So what is, we end up in the product benzoin. This is cyanohydrin of benzoin. Cyanohydrin of benzoin loses Cn minus, or we can say that it forms HCN. So H plus is removed from here and Cn minus is here, so it forms HCN. So by the elimination of one HCN molecule, it forms benzoin. Okay, so the first step, what is the first step here? The first step, it is the addition of Cn minus to the aldehyde, which forms cyanohydrin. Then cyanohydrin, it forms a carbanion intermediate in the step 2, which leads to the formation of cyanohydrin of benzoin. So cyanohydrin is formed, then cyanohydrin of benzoin is formed by how the cyanohydrin of benzoin is formed? By the addition of base catalyst addition of cyanohydrin onto another aldehyde, second aldehyde molecule, so that you get cyanohydrin of benzoin. And cyanohydrin of benzoin, when it loses one HCN, it will result in the formation of benzoin. Thank you.